Welcome back, DIY enthusiasts. Today we have an exciting project in store for you. You will be able to create your own IoT temperature monitor using ESP8266 Wi-Fi module and of course temperature sensor. By the end of this tutorial, you will be able to remotely monitor the temperature from your smartphone using Arduino IoT server. So let's dive right in. Before we begin, let's get acquainted with our components. We have the very still ESP8266 Wi-Fi module, the DHT11 temperature and humidity sensor, and Arduino to program the ESP module, and some jumper wire for connection. Next, let's connect the DHT11 sensor to the ESP module. Connect the VCC pin of DHT sensor to 5V and ESP to 3.3V. Be careful, ESP module do not have any regulator, so you should only connect it to 3.3V. And the digital pin to digital input pin to an ESP module. Now, going to the hardest part, programming. Since I am using Arduino Cloud IoT, it's so everything will be done by the site. Once you have registered in your account on the IoT platform, you will land on the dashboard. To begin, select the IoT Cloud option. Here, you will find a list of your things. Then, create a new project. For our project, we will need to track temperature and humidity. Click on the Create button to set up your first variable. Name your project, for instance, my room. Now, add a variable by clicking Add Variable. Let's start with temperature. Choose temperature as the variable type and select either Celsius or Fahrenheit based on your preference. Since this is a sensor, you will set it to read only and hit Add Variable. Again, with the humidity variable, choose percentage relative humidity as the type of variable. Set to read only, same as temperature. Then after this, click Add Variable. Moving on the device configuration, select the device you are working with. In my case, it's the ESP8266 module. Then choose the generic ESP8266 module as your module if you are using the same module like me. Feel free to name your device as you like or follow the recommended name. For future security, don't forget to download and save the PDF containing your security key. You will use it later. Then click Continue and then choose Create. Provide your network password or other required information. Now, before we start coding, let's create a dashboard to visualize the data. Create a new dashboard. Let's call it Room. Begin by adding gauge for temperature, then link it to the temperature variable. For maximum value, I can recommend 50 degrees Celsius. It's more than enough. Next, add a humidity gauge. Connect it to the humidity variable. Since room humidity usually range between 30 and 70%, we will set the thunder shield at 70. Feel free to customize the layout and design according to your preference. With the dashboard set up, let's move on to coding. Since we are using the IoT Cloud platform, you can program your device directly from the website. Then click Open the Full Editor. In the code, make sure to integrate the logic to read and send temperature and humidity data. You will find the necessary guidance in the platform documentation. In the previous section, we set up our IoT Cloud account, created variables for temperature and humidity, configured our ESP device, designed a dynamic dashboard, and now it's the time to bring it all to life. With some coding magic, let's jump right in. Before we dive into coding, let's prepare our environment. First, define the pins you have connected to your DHT sensor to it. In my case, I am using pin number 2. Also specify the type of DHT sensor you are using. Now let's create a loop named Send sensor. Within this loop, you will define H as humidity and T as temperature. Readings from the sensor. Link these variables to the ones we added to our device before. Remember, we will be using DHT library to communicate with the sensor. If you encounter any error at this point, make sure you properly include the library and check for any capitalization issue. We will be reading the temperature and humidity data within 1 second delay. Ensuring constant data updates after confirming your code accuracy, it's time to send it to the ESP module. Before uploading the code, ensure your ESP module is in programming mode. To convert it to programming mode, connect pin GPIO 0 to ground and power up your Arduino. Select the operator port and ESP type. Now you are ready to upload the code. Once the code is uploaded, usually at 100%, transition your ESP module from programming mode to normal mode by disconnecting the GPIO 0 pin from ground. Connection. Give it a quick reset and there you have it, a seamlessly programmed ESP module. Back to main page, and now you will notice your ESP module device is online and connected. Navigate to your dashboard. The real-time temperature and humidity data is beautifully displayed. For interactive test, try touching your sensor. You might see a slight temperature increase due to your body heat. Remember, this data is viewable on both the web and mobile dashboard. And don't worry about losing any configuration. Everything you have done is securely saved within your IoT Cloud account. Conclusion: it's a complete walkthrough of setting up your ESP module to monitor the temperature and the humidity using the IoT Cloud platform. We have converted each step from coding to sensor to observing real-time data on your dashboard. The possibilities from here are endless. You can expand this project, add more devices, or integrate other sensors. Thanks for joining us, and until next time, happy tinkering.